Question 1. Based on the information, Mr. Stevens is troubleshooting the ER system that is not providing adequate cooling despite the compressor running normally and correct refrigerant charge verified. The indoor units show erratic temperature fluctuations. What should Mr. Stevens primarily investigate to resolve this issue? A. Improperly calibrated thermostats causing incorrect feedback signals. B. A refrigerant leak in the outdoor condenser coil reducing system capacity. C. Blockage in the liquid line causing insufficient refrigerant flow. D. Fault compressor windings causing intermittent operation. Answer. Correct answer. A. Explanation. Erratic temperature fluctuations in indoor units of a EL system despite normal compressor operation and refrigerant charge usually point to control issues, particularly thermostat calibration or sensor feedback. ERF systems rely heavily on precise electronic communication for modulating refrigerant flow. Refrigerant leaks or blockages would reduce overall capacity and cause stable but output, not fluctuations. Compressor winding faults would likely cause compressor cycling or failure, not stable running. Hence, troubleshooting control calibration is key, aligning with the principle that system controls are critical in advanced HVACR systems like EOF. Question 2. When considering the thermodynamic cycle of a standard vapor compression refrigeration system, which statement best explains the role of the expansion device in overall system efficiency? A. It increases refrigerant pressure to improve condenser heat rejection. B. It decreases refrigerant pressure to create a temperature drop before the evaporator. C. It regulates the compressor speed to match cooling load demands. D. It absorbs heat from the refrigerant to increase evaporator efficiency. Answer. Correct answer. D. Explanation. The expansion device reduces pressure causing refrigerant to cool, but it does not absorb heat itself. If this occurs in the evaporator, its primary function is to create the pressure drop that allows evaporation at low temperature. The device does not increase pressure nor regulate compressor speed, which are other system components' roles. Absorbing heat directly is incorrect. The expansion device's proper functioning is vital, maintaining the refrigeration cycle's thermodynamic balance and system efficiency by ensuring the refrigerant enters the evaporator at the correct conditions. Question 3. Considering the electrical systems of HVACR, Mrs. Patel observes that a compressor motor is overheating and tripping on overload. Upon inspection, she notes the motor winding resistance is within specification, but the voltage supply fluctuates frequently. What is the most probable cause of the motor issue? A. Mechanical binding within the compressor increasing load. B. Voltage instability causing motor current to spike intermittently. C. A failed start capacitor preventing proper motor startup torque. D. Incorrect motor rotation direction reducing efficiency. Answer. Correct answer. B. Explanation. Voltage fluctuations cause inconsistent motor current draw leading to overheating and overload trips despite normal winding resistance. Mechanical binding typically causes constant high load and overheating, but not related to voltage fluctuation. A failed start capacitor affects startup but usually causes failure to start, not overheating under running conditions. Incorrect rotation causes performance, but not necessarily overheating due to voltage instability. Thus, voltage supply quality is critical for motor health, reinforcing the importance of stable electrical supply for HVACR motor longevity. Question 4. Given the circumstances, technician Mr. Lee is measuring airflow in a duct system and observes unusually high static pressure readings with low airflow volumes. What is the most logical cause of this scenario? A. Oversized ductwork causing reduced velocity and low static pressure. B. Blocked or closed dampers restricting airflow and increasing static pressure. C. Faulty blow of motor running at excessive speeds. D. Leaky duct joints causing loss of static pressure. Answer. Correct answer. C. Explanation. High static pressure with low airflow usually indicates a restriction causing air to struggle through, which contradicts excessive blower speed. A faulty motor running too fast would generally increase airflow and static pressure. Oversized ducts, low velocity and static pressure, not increase. Blocked dampers restrict airflow causing high static pressure, which fits the scenario best. Leaky ducts, low static pressure due to air loss, not increase. Hence, Duct restrictions like blocked dampers are primary suspects for such symptoms in airflow diagnostics. Question 5. In a modern context of refrigerants, is Gomez must recommend a refrigerant for a retrofit that minimizes environmental impact but retains high efficiency in a commercial refrigeration system? Which refrigerant type should she suggest? A. Hydrochlorofluorocarbon HFCSU to moderate ozone depletion potential. B. Hydrofluorocarbons HFCS with zero ozone depletion but high global warming potential. C. Natural refrigerants such as CO with low global warming potential and no ozone depletion. D. Chlorofluorocarbons CFCS for their superior thermodynamic properties despite fade-out. Answer. Correct answer. C. Explanation. Natural refrigerants like CO have zero ozone depletion and very low global warming potential, aligning with current environmental regulations and sustainability goal. HFCS have ozone depletion potential and are being phased out. HFCS have no ozone depletion but significant global warming potential, making them less desirable long term. CFCS are banned due to their high depletion. Choosing natural refrigerants ensures compliance and environmental responsibility without compromising system performance. Question 6. Through the lens of psychrometrics, Chen needs to design an HVAC system for a humid climate. Which property on the psychrometric chart most directly influences his choice of dehumidification strategy? A. Dry bulb temperature, as it determines sensible cooling load. B. Wet bulb temperature, as it indicates total heat content in the air. C. Dew point temperature, as it signifies the temperature at which moisture condenses. D. Relative humidity, as it affects occupant comfort but not system sizing. Answer. Correct answer. D. Explanation. Relative humidity directly relates to moisture content and occupant comfort, guiding dehumidification needs. Dew point temperature shows condensation threshold but is less actionable for control strategies. Dry bulb temperature governs sensible cooling but not moisture removal. Wet bulb temperature reflects combined sensible and latent heat but is less intuitive for direct dehumidification design. Relative humidity is the key psychrometric property influencing effective humidity control strategies in HVAC system design. Question 7. The primary reason for Davis to perform a deep system evacuation before charging refrigerant is to A. Remove moisture and non-condensable gases that degrade system performance. B. Increase the refrigerant charge capacity of the system. C. Clean the internal components from oil deposits. D. Test the system's electrical continuity during installation. Answer. Correct answer. C. Explanation. Deep evacuation primarily removes moisture and non-condensable gases which cause corrosion, reduce efficiency, and can damage the compressor. It does not increase refrigerant charge capacity or clean oil deposits, which require other procedures. Electrical continuity testing is unrelated to evacuation. Proper evacuation prevents system contamination, critical to long-term reliable HVACR system operate, and aligns with best installation and maintenance practices. Question 8. While examining the safety procedures, technician Roberts is about to service an energized HVAC system. Which step is essential to prevent electrical shock hazards according to OSHA best practices? A. Testing system voltages only after completing repairs. B. Wearing insulated gloves and verifying lockout before work. C. Disconnecting the power at the nearest breaker without lockout. D. Using a non-contact voltage tester without further safety precautions. Answer. Correct answer. D. Explanation. Wearing proper PPE and verifying lockout ensures safety by preventing accidental energization. Simply disconnecting power without lockout risks re-energizing during service. Testing voltages only after repair ignores pre-service safety checks. Non-contact voltage testers are useful but cannot replace comprehensive safety procedures. OSHA standards emphasize lockout and PPE as critical steps for safe HVACR electrical servicing. Question 9. During the process of diagnosing a refrigeration system with low superheat, Mr. Ahmed notes a high suction pressure and abnormally high compressor amps. Which of the following best explains this condition? A. An overcharged refrigerant system causing compressor flooding. B. A restricted metering device limiting refrigerant flow to the evaporator. C. A faulty condenser fan reducing heat rejection capacity. D. Undersized refrigerant piping causing pressure drop. Answer. Correct answer. A. Explanation. Low superheat and high suction pressure with high compressor amps typically indicate liquid refrigerant flooding the compressor due to overcharge or malfunctioning metering device. Restricted metering device would cause low suction pressure and high superheat. Faulty condenser fan reduces condensing efficiency but doesn't directly cause low superheat. Undersized piping causes pressure drops but wouldn't directly create high suction pressure and amps. Overcharge risks compressor damage, making this diagnosis critical. Question 10. Taking into account variable speed drives, VSD, and HVACR, Lopez is evaluating their impact on system performance. Which of the following most accurately describes a VSD's improved HVACR system efficiency? A. They maintain fixed compressor speed for consistent capacity. B. Adjust motor speed to match load demands, reducing energy use. C. They bypass safety controls to increase airflow at peak loads. D. They convert AC to EC without changing motor speed. Answer. Correct answer. C. Explanation. VSDs improve efficiency by adjusting motor speed to precisely match load demands, reducing energy waste from running at full speed when unnecessary, and maintaining fixed speed contradicts VSD functionality. Bypassing safety controls is unsafe and contrary to best practices. VSDs convert AC to EC for motor speed control. The key efficiency gain comes from variable speed matching load. Principle is central to modern energy-efficient HVACR system design and operation. Question 11. When analyzing a commercial refrigeration system, Mr. Martinez finds the condenser coil temperature is excessively high despite normal fan operation. Which factor most likely causes this issue? A. Dirty condenser coil restricting heat transfer. B. Undersized expansion valve limiting refrigerant flow. C. Overcharged refrigerant causing increased pressure. D. Faulty evaporator fan reducing heat load on condenser. Answer. Correct answer. B. Explanation. A dirty condenser coil would definitely cause high coil temperature, but with normal fan operation and the observed symptoms, an undersized or malfunctioning expansion valve limits refrigerant flow, leading to higher condensing pressures and temperatures. Overcharge raises pressures but generally elevates system temperatures more uniformly. A faulty evaporator fan lowers evaporator load but does not directly increase condenser temperature. Correct diagnosis involves understanding refrigerant flow impact on condenser conditions. Question 12. Taking into account the principles of psychrometrics, Huang is tasked with reducing latent heat in a high humidity environment. What is the most effective approach here? Increase dry bulb temperature to evaporate moisture. B. Use a cooling coil to lower air temperature below dew point. C. Increase ventilation rates to dilute indoor humidity. D. Raise relative humidity to saturate the air. Answer. Correct answer. D. Explanation. Lowering air temperature below the dew point causes condensation and removes latent heat, making cooling coils effective. Raising relative humidity is counterproductive as it increases moisture content and latent heat load. Increasing dry bulb temperature does not remove moisture, it just increases sensible heat. Ventilation can help but often only dilutes moisture without removing it effectively. Therefore, cooling dew point is the core method to control latent heat in humid environments. Question 13. Given the circumstances, Mr. Kim needs to troubleshoot a blow motor that hums but does not start. Which is the most probable cause? A. Failed start capacitor preventing initial torque. B. Incorrect wiring of the motor phases. C. Overloaded circuit breaker limiting power. D. Worn motor bearings causing mechanical resistance. Answer. Correct answer. C. Explanation. A humming motor that does not start typically indicates electrical issues such as an overloaded or tripped breaker restricting current. A failed start capacitor usually results in the motor attempting to start but not running properly, often without humming. Incorrect wiring may cause the motor to run in reverse or fail to start, but not typically just humming. Worn bearings cause noise and mechanical resistance, but do not humming. Electrical supply issues are often the primary suspect for humming without rotation. Question 14. Under the assumption that an HVAC system is experiencing short cycling, is it Alvarez suspects the cause is related to sensor placement? How might sensor positioning affect system operation? A. Sensors placed near supply air outlets cause premature cycling due to inaccurate load sensing. B. Sensors on return air ducts lead to overcooling and longer run times. C. Sensors located in shaded areas cause delayed response to temperature changes. D. Sensors placed too far from equipment reduce communication reliability. Answer. Correct answer. A. Explanation. Placing sensors near supply outlets exposes them to artificially conditioned air, causing the system to detect incorrect temperatures and cycle prematurely. Return air sensors better reflect overall room conditions, preventing short cycling. Shaded sensor placement delays detection but not necessarily causes cycling. Distance affects signal strength but is less critical than location in conditioned airflow paths. Proper positioning is essential for stable HVAC control. Question 15. From a practical standpoint, HRConquer is evaluating the impact of oil types on compressor performance. Why is using the correct oil type critical in refrigeration compressors? A. It improves heat transfer in the evaporator. B. It reduces lubricant miscibility with refrigerant, preventing foaming. C. It decreases the electrical load on the compressor motor. D. It controls refrigerant pressure in the condenser. Answer. Correct answer. D. Explanation. Using the correct oil type ensures proper lubrication and prevents refrigerant dilution in the compressor crankcase, which can cause foaming and inadequate lubrication. This directly affects compressor reliability and efficiency, but oil does not control condenser pressure or electrical load. Heat transfer in the evaporator is unrelated to oil. Correct oil choice aligns with manufacturer specs to maintain compressor health, overall system balance. Question 16. In the context of HVAC electrical controls, Jackson notes that a contactor coil continuously hums without engaging the contacts. What is the most likely underlying issue? A. Coil voltage is insufficient due to wiring faults. B. Mechanical failure of the contactor preventing contact closure. C. Overcurrent causing coil burnout. D. Thermostat is stuck in the open position. Answer. Correct answer. C. Explanation. A humming coil without engagement often results from coil burnout or short circuit causing inadequate magnetic pull. Insufficient voltage might prevent coil energizing altogether, not humming. Mechanical failure could prevent contact closure but would not cause coil humming. A stuck thermostat would prevent coil energizing, not cause humming. Understanding coil electrical and mechanical interaction is key to diagnosing contactor faults. Question 17. Illustrated by Ewan experience, what is the primary safety risk when brazing refrigerant lines without proper evacuation? A. Moisture causing ice formation that damages the compressor. B. Oxygen present causing explosive reactions with brazing material. C. Excess nitrogen diluting refrigerant charge. D. High pressure buildup causing valve failure. Answer. Correct answer. B. Explanation. Brazing lines without proper evacuation risks oxygen presence, which can react violently with brazing flame or materials, causing fire hazards or explosions. Moisture is damaging but not an immediate explosive risk during brazing. Nitrogen is inert and often used for purge. Excess does not dilute refrigerant significantly. High pressure can cause failures, but is not typically. The brazing hazardous system. The pressurized. Safety protocols emphasize purging and evacuating lines before brazing. Question 18. When considering airflow principles, Patel observes that a duct system shows a significant difference between total pressure and static pressure measurements at a branch. What does this indicate about airflow characteristics? A. High velocity pressure indicating increased airflow velocity. B. Low static pressure indicating duct leakage. C. Equal static and total pressure indicating no airflow. D. High static pressure causing reduced airflow velocity. Answer. Correct answer, A. Explanation. Total pressure equals static pressure plus velocity pressure. A significant difference means velocity pressure is high, indicating increased airflow velocity at that point. Low static pressure often signals leaks, but not total pressure differences. Equal static and total pressure would imply zero velocity pressure and no airflow. High static pressure with reduced velocity is generally not indicated by a large pressure difference. Understanding pressure components helps diagnose duct system performance. Question 19. The general consensus is that preventive maintenance is crucial for system longevity. Which preventive maintenance task most directly impacts energy efficiency in HVAC systems? A. Lubricating motors and bearings monthly. B. Cleaning or replacing air filters regularly. C. Checking refrigerant pressure quarterly. D. Tightening electrical connections annually. Answer. Correct answer, C. Explanation. Correct refrigerant pressure ensures optimal system operation and energy efficiency. Improper charge leads to overwork or inefficiency. Cleaning filters affects airflow and indoor air quality but is less directly related to energy efficiency than refrigerant charge. Lubrication and electrical connections maintenance impact reliability and safety but not primary energy use. Hence, regular pressure checks are for maintaining peak HVAC system performance. Question 20. Given the scenario that Mr. Williams needs to interpret a wiring diagram showing multiple relays and switches, what is the best approach to efficiently troubleshoot an electrical fault in the system? A. Replace all relays and switches before testing. B. Test components systematically using continuity and voltage checks based on schematic flow. C. Disconnect power and replace wiring harnesses entirely. D. Bypass faulty relays to maintain system operation during testing. Answer. Correct answer, D. Explanation. Systematic testing based on schematics allows precise fault isolation, saving time and costs. Replacing all components blindly or wiring harnesses is inefficient and costly. Bypassing relays is dangerous and violates safety protocols. It may damage equipment or pose hazards. Proper troubleshooting involves methodical checks guided by wiring diagrams to identify the root cause without unnecessary replacements or unsafe shortcuts. Question 21. In the absence of proper refrigerant oil circulation, Mr. Rivera notices decreased compressor lubrication leading to premature wear. Which factor most influences oil return in a refrigeration system? A. Proper system charge and correct refrigerant velocity through suction lines. B. Increased condenser pressure to push oil through the system. C. Larger diameter liquid line to reduce oil trapping. D. Higher evaporator temperature for improved oil vaporization. Answer. Correct answer, C. Explanation. Oil return depends largely on maintaining refrigerant velocity sufficient to carry oil through suction lines. However, liquid line size impacts oil trapping before suction side. Larger diameter liquid lines reduce velocity, increasing oil trapping risk. Increasing condenser pressure affects system pressures but not directly oil return. Higher evaporator temperature can reduce oil viscosity but doesn't guarantee return. Correct oil circulation is critical to compressor longevity and system reliability. Question 22. When faced with diagnosing low airflow in a forced air system, Ms. Carter finds duct static pressure abnormally high. What is the most likely cause affecting airflow? A. Dirty or clogged air filters restricting flow. B. Oversized ductwork reducing velocity pressure. C. Fan blade damage increasing airflow. D. Leaky ducts causing static pressure rise. Answer. Correct answer, B. Explanation. High static pressure indicates airflow restriction or resistance. Oversized ducts lower velocity and thus velocity pressure but typically decrease static pressure. Dirty filters are common causes but primarily reduce total airflow without necessarily raising static pressure significantly. Fan blade damage reduces airflow capacity. Leaky ducts reduce static pressure due to loss of air volume. Correct diagnosis requires understanding pressure components and duct design principles. Question 23. Considering the safety protocols, Mr. Simmons is about to repair a refrigerant leak in an enclosed space. What personal protective equipment (PPE) is essential for this task? A. Safety goggles and nitrile gloves for chemical exposure protection. B. Flame-resistant clothing and respiratory protection in case of flammable refrigerants. C. Hearing protection due to compressor noise. D. Steel-toed boots to prevent foot injuries. Answer. Correct answer. A. Explanation. Chemical exposure protection like safety goggles and gloves is mandatory when handling refrigerants to prevent skin and eye injuries. Flame-resistant clothing and respirators are essential only if the refrigerant is flammable or if confined space hazards exist, but not universally. Hearing and foot protection are general PPE but less critical specifically for refrigerant leak repairs. Adhering PPE ensures technicians' safety and compliance with OSHA and EPA guidelines. Question 24. Based on recent studies, Mrs. Foster is selecting an expansion device for a heat pump operating in both heating and cooling modes. Which type of expansion device is most suitable? A. Fixed orifice tube for simplicity and low cost. B. Thermostatic expansion valve (TXV) for adaptive refrigerant flow control. C. Capillary tube for precise refrigerant metering. D. Electronic expansion valve only suitable for cooling mode. Answer. Correct answer. A. Explanation. Thermostatic expansion valves (TXV) adapt flow to load changes and are suitable for most systems, but fixed orifice tubes are sometimes preferred in heat pumps for reliability in dual modes. Capillary tubes provide fixed flow and lack adaptability. Electronic expansion valves provide precise control but may not always be suited for heat pumps dual mode. Choosing the right device balances complexity and operational reliability. Question 25. Under the assumption that a refrigeration system exhibits excessive superheat at the evaporator outlet, what is the primary cause? A. Undersized evaporator causing refrigerant starvation. B. Overcharged refrigerant resulting in flooding. C. Restriction in the liquid line reducing refrigerant supply. D. Evaporator fan operating at too high speed increasing heat transfer. Answer. Correct answer. D. Explanation. Excessive superheat indicates insufficient refrigerant or excessive heat input. A restriction in liquid line or undersized evaporator can cause low superheat due to starvation, not excess. Overcharge typically leads to low superheat flooding. Fan speed increasing heat transfer can increase evaporator outlet temperature causing superheat rise. Proper balance of airflow and refrigerant supply is key to controlling superheat. Question 26. When evaluating the relationship between refrigerant pressure and temperature, Mr. Chang uses a PT chart. Which concept best explains why this relationship is critical for HVACR system diagnostics? A. It helps determine compressor motor efficiency. B. It identifies saturation points to assess charge status and operating conditions. C. It measures airflow velocity in ducts. D. It predicts oil viscosity changes under different pressures. Answer. Correct answer. A. Explanation. The pressure-temperature relationship is fundamental to identifying refrigerant saturation states, which helps diagnose charge and system conditions, not motor efficiency. It does not directly relate to airflow or oil viscosity changes. Understanding PT charts enables accurate superheat and subcooling calculations essential for efficient and safe system operation. Question 27. Considering the implications of airflow measurement techniques, Bennett must choose an instrument for precise velocity pressure readings in ducts. Which tool is most appropriate? A. Manometer measuring static pressure only. B. Pitot tube measuring velocity pressure. C. Anemometer measuring air temperature. D. Multimeter measuring electrical current. Answer. Correct answer. B. Explanation. A pitot tube measures velocity pressure by detecting dynamic pressure in airflow and is standard for duct velocity measurements. Manometers measure static or differential pressure but not velocity pressure alone. Anemometers measure air velocity but not pressure. Multimeters measure electrical parameters unrelated to airflow. Accurate velocity pressure measurement aids in assessing duct system performance and airflow calculations. Question 20. In light of recent developments, Mr. Turner is addressing a compressor failure caused by liquid slugging. What system condition most commonly leads to this? A. Overcharged refrigerant causing flooding of the compressor with liquid refrigerant. B. High superheat causing insufficient liquid refrigerant in the evaporator. C. Excessive evaporator airflow drying the refrigerant. D. Undersized suction line reducing refrigerant velocity. Answer. Correct answer, B. Explanation. Liquid slugging occurs when liquid refrigerant enters the compressor, often caused by overcharge or poor metering. High superheat indicates less liquid, reducing slugging risk. Excessive airflow dries refrigerant and lowers slugging chances. Undersized suction line affects velocity but less directly linked to slugging. Proper charge and metering device adjustment prevents slugging and compressor damage. Question 29. By evaluating control systems, is Delgado notices the variable frequency drive VFD is not responding correctly to load changes. What is the best initial troubleshooting step? A. Bypass the VFD to run motor at full speed. B. Verify control signal input and sensor feedback for accuracy. C. Replace the motor windings. D. Increase the VFD output voltage manually. Answer. Correct answer, C. Explanation. Troubleshooting VFD issues starts by verifying control inputs and sensor feedback to ensure proper signal communication. Bypassing VFD can damage equipment and is unsafe. Increasing output voltage manually risks overloading motor. Motor winding replacement is a last resort after confirming VFD and control signals. Proper diagnostics rely on systematic checking of control and feedback loops. Question 30. Throughout the course of preventive maintenance, Mr. O'Neill wants to ensure system refrigerant levels remain optimal. What measurement best indicates if the system charge is correct? A. Suction pressure alone. B. Subcooling and superheat values measured simultaneously. C. Liquid line temperature only. D. Compressor amp draw only. Answer. Correct answer, A. Explanation. Correct charge is best verified using subcooling and superheat measurements together to assess refrigerant state at both evaporator and condenser. Suction pressure alone is insufficient as it can be affected by load and temperature. Liquid line temperature and amp draw provide indirect information but are not definitive. Balanced subcooling and superheat measurements reflect accurate charge and system health.